All right. Hello, everyone, and happy Friday. Thank you to that person who left that like. It's always good when someone leaves you a like before the stream starts. That means someone's looking for it. I apologize. I set the stream for I think 10:30 initially, and I thought I had an informal meeting with some people at noon, but it was actually at 11. So I missed that, and it's my day off, and I got my wires crossed up and entangled. So I had to move this stream to 1 o'clock. So let me make sure I can see myself on YouTube. Yep, there we are. Who's ever watching, please feel free to shout yourself out. Let me know if you have any questions, comments, or jokes. One of my college professors used to say that. Questions, comments, jokes. Anyone? Okay, so I can see myself. Should I share this over on my original channel? I'm always, yeah, I'll do it. Okay, I'm going to start the intro and then I'm going to share this on my original channel and then I will present uh, what it is we're going to present today. And then I'm going to hop off because I have some other things to do and to see about. So today we're going to talk about, well, we're going to speculate on the planet Earth and things that we have control over as man and things that we don't. Because what I'm seeing, and I think to some degree, I've always known this, and I think most of humanity has known this. Well, a percentage of humanity has known this, and that's that there are things happening with the planet Earth, both inside the planet itself and then in the atmosphere and then outside of the planet, there are things happening that are out of our control as humanity. So I think that's going to be the underlying theme of this stream. There were a couple of earthquakes this week, and I've been receiving articles about the Earth's core stopping and changing direction, and even the magnetic poles shifting. So those are all areas we're going to visit today. And I'm probably going to spend more time on the Earth's core and touch upon the shifting magnetic poles, and then I'll just briefly touch on the earthquakes. So I'll see you on the other side of the intro. All right, everyone. Welcome back to Big Discussions 76, Science and Technology. First of all, please like this stream, please share it, and please subscribe to the channel, especially if you're new. For those of you watching, thank you to those of you who are watching and who just came in. I saw the likes kind of jump up a little bit. Feel free to shout yourselves out there in the chat. And also, if you're watching this and you have a background in tectonics and earth science and anything applying to what I'm going to discuss today, and you think you'd like to come up and have a Q&A and talk about that and educate me and my audience on your field of expertise, please feel free to reach out. I can be contacted in multiple ways, but that email address right there in the second line, Big Discuss 76 at bigwordsarepowerful.com. I know that is a mouthful. That is a good way to reach me. I do not have a super chat or AdSense over here on this channel as of yet. So if you want to make a donation to the channel, that information is here. Okay. So today's stream. So the cool thing about this stream, sorry, the cool thing about this channel and the streams on this channel is that it's forcing me to learn. So I have a background in pharmacology and toxicology, but the STEM acronym is broad, and there are many, many disciplines within those four letters. So in order to run a STEM channel, I have to educate myself on what's happening in other fields. So that's the beauty of this channel. For me, is that it's forcing me to continue to learn and add to my own body of knowledge. It's Black History Month. I have numerous Black History related videos in my catalog. If you go back, you'll see them. I've talked about Percy Julian and the Black astronauts. So if you're interested in those things, please go ahead and take a look back at those. Sheed, we here. Thank you for being here, Sheed. I'm gonna take a sip of my tea and then I'm gonna jump in. So where did today's topic come from? Well, there's a lot happening in the world. There is a lot happening in the world, and I don't always watch the mainstream news, but someone in my personal circle alerted me that there was a big earthquake over in Turkey. So I was one of the last ones. Well, I probably wasn't one of the last ones to find out about that, but there was a big earthquake in Turkey, and there was a big earthquake. No, there wasn't a big earthquake. There was an earthquake in my home city of Buffalo, New York. So that's part of where the stream came from. And I'm not gonna. I'll get to that at the end. But I've been getting articles talking about things happening with the planet Earth, and I think that the news from this week provides a nice jumping off point to introduce those concepts of the Earth's core, what's happening with the Earth's core, and what's happening with and changes in the Earth's magnetic field. So I'm going to take a sip of my tea here, and then I'm going to jump in. Gentlemen, thank you for coming through. Please hit that like button. So, as I told many of you, I have taken an interest in the climate discussion, and I, for numerous reasons, I'm going to tiptoe around that, and I'm going to be very, very careful about speaking on that because, as I've discovered after just taking a short look at that community, because it's a community, and taking a look at the arguments within that community, as they say, it's a very prickly pear, and it's a very fierce debate, and it's a very, very fierce discussion. But I saw something in one talk. I'm not going to reveal the gentleman right now who I pulled this slide from, but the gentleman basically made the argument that there are multiple things that we as human beings have to think about in terms of climate and climate change and what's happening with the earth. And there are numerous fields that you have to have a knowledge of to be able to make conclusions about what's happening with our planet Earth. Because the Earth is arguably a bit of a living organism itself. I mean, it's not reproducing, but it goes through cycles. It has different regions, and there are different, very, very different parts to the Earth. We live on the surface of the Earth, and we look up at the clouds and we look up at the sun, and we tend to think of it as that. We're driving around. We tend to think of the Earth in terms of our daily lives, but there are a lot of processes inside of the planet and outside of the planet that impact it. So those disciplines that this particular scientist talked about include. So this particular slide said, "What is climate, and what area of expertise is required to master it?" An understanding of climate requires an amalgamation of astronomy, solar physics, geology, geochronology, geochemistry, sedimentology, tectonics, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, and history. So I'm sharing this slide in this instance just to convey that there are a lot of, when you think about the planet Earth and things that happen to it and things that we as humans experience in terms of our own consciousnesses and what we can see and sense, there are a number of sciences that you have to know and understand to to know and understand what's going on with the planet Earth. Let's go to outer space for a moment. So, we know that we are in a eight planet because Pluto was demoted. We're in a eight planet solar system with a singular star, and the Earth is the third planet out from the sun. And what makes the planet Earth unique? Well, a couple things. Well, we have a breathable atmosphere, and we have liquid water, and we have clouds, and the Earth sits in what is known as a habitable zone. It's in that sweet spot between Venus and Mars, where we can have a breathable atmosphere and we can have water, which are necessary components for life as we know it. So the Earth sits in the ideal position in our solar system to allow us to live. But there's the sun. The sun gives off a radiance, so it gives us sunlight. But the sun is also arguably a living, breathing thing as well. The sun goes through its own cycles. The sun creates a solar wind. All right. The sun has its own gravitational field, and it's the sun that keeps all of the eight planets orbiting around it. and all of the other planets have their own gravitational fields, and the Earth has its own gravitational and magnetic field, right? So this image right here is showing the Earth's is a depiction of the Earth's magnetic field. Okay, so I just said all that to set up the fact that the Earth is not in its own unique. It's not in its own singular vacuum. There are other things acting on it. There are uh, there are outputs from the sun, and there are numerous dynamics between the Earth and the sun and the other planets. So those are things that are happening outside of us as human beings that we have no control over. So let's talk about what's happening inside the Earth that we as humans arguably have no control over. So I'm going to pull up an article here. These are short. I promise they're short. There is let's see, I pulled up an article from General Dynamics. Popular Mechanics, not General Dynamics, it's Popular Mechanics. Thank you all for being here. Please hit that like button if you haven't. If you want to donate something to the channel, my Cash App and PayPal are there. This is a short piece, I promise. Oh, that the thumbnail for this stream. This piece is called Earth's Inner Core Stopped Spinning. Okay, and what that illustration shows you is that we live on the center, we live on the surface of the Earth, and that's pretty much what we know. But there are layers to our planet, and there's a core in the middle. Okay, there's a molten core within the middle, and there are all kinds of changes and gyrations. Gyrations may not be the right word, but there are all sorts of processes happening in the center of this planet that drive some things that happen on the outside of the planet. Okay, it's like volcanoes, like tectonic shifts, shifts in plates, and these things give rises to earthquakes. So that's what when I look at that image, that's what I see. So apparently we know the planet rotates. Okay, but apparently the core doesn't rotate with it in the same direction, and the course can stop and change directions itself. So let's see what this article says. This was written by Tim Newcomb, and it was published on January 23rd, 2023. And the subtitle says, "Yeah, the inner core spins separate from the rest of the Earth." So again, I'm going to keep emphasizing this. There are processes happening within the planet that man does not impact. Okay. Earth's inner core stopped spinning, but don't fret. It appears this happens from time to time, say every 7 decades or so. A new study published in Nature Geoscience by geophysicists Yi Yang and Zidong Song of Peking University in Beijing explored the nature of movement of Earth's inner core, largely made up of iron and molten liquids. They found the inner core's movement recently reduced enough they consider it paused. All of what seems to be associated with a gradual turning back of the inner core as a part of an approximately 7 decade oscillation. The last turning point was in the early 1970s. Our understanding of the Earth's inner core doesn't have a strong history, so there's a lot we don't know about that and what it means. Ancient days, of course, had folks believing in a hollow core. Then came the understanding of iron and molten mixture making up Earth's middle, coupled with the theory of spinning happening separate from the rest of the Earth. Some confirmed the spinning theory in 1996. We don't quite know the speed of spinning, but it appears that maybe because the inner core remains in a constant state of flux and switches directions roughly every 7 decades, thanks to electromagnetic imbalances in gravitational forces. The new study further tracked seismic waves through the core to see how they played out on the other side of Earth. This globally consistent pattern suggests that inner core rotation has recently paused, the study says. With the spin changing throughout the decades, the authors believe there's an interplay between the spinning of the core and Earth's mantle, and not just a spinning core for spinning's sake. The multi-decadal periodicity coincides with changes in several other geophysical observations, especially the length of day and magnetic field. The authors write, these observations provide evidence of dynamic interactions between the Earth's layers from the deepest interior to the surface, potentially due to gravitational coupling and the exchange of angular momentum from the core and mantle to the surface. Okay. This link is in the description box below. I'm going to drop the link right here in case any of you want to keep a copy for yourself. Okay. And again, everyone, the theme is, if you're just coming in, please hit that like button. If you're new to the channel, please subscribe. The theme is, there are things happening with our planet that we as humans are not controlling, and there are things that we are not impacting. There are things happening every day as we're going on throughout our lives that we're not even thinking about, and we don't think about them until some natural occurrence like an earthquake happens, like the one over in Turkey. But there are things going on all the time that we are unaware of. I'm going to read another piece. It's very short, and it's from CNN. I don't. I think it's legitimate, so I'm going to read it. Okay. Let's see. Aquateki, everyone's greeting themselves. Extended clip says 2133, chapter 2133 of the Quran. And he is the one who created the night and day and the sun and the moon, each floating in its own orbit. Okay. All right. Sheet says I think Elon Musk touched on the theory of the magnetic pole might reverse. Okay. Extended clips. He has another one. Surah 25, V61, Qian. Blessed is the one who placed the constellations in heaven and placed therein a lamp and a moon giving light. Okay. Thank you for those extended clips. All right. So the CNN piece, where is this? Okay. The thing I don't like about this CNN site is they have this large banner at the top. Oh well, we'll just deal with it. Okay. And this is an opinion piece. All right. This is entitled Opinion. The Earth's core is changing. What does that mean for us? Okay, that gentleman right. No, I don't want that. That gentleman right there, does anyone know who that is? This is a science and technology channel. This gentleman is synonymous with science and technology. Does anyone know who that is? I'm sure Aquatechie knows who that is. Aquatechie knows a lot. Does anyone know who that is? Alicia got it. Yep. This is Dr. Michio Keku or Kaku. Okay. So when you start delving into the science spaces and especially into the physics realm, his face pops up pretty regularly. So he is a theoretical physicist. So he's speaking on everything from the Earth's core to its magnetic field to string theory. So there's a lot of content out there on this gentleman. I'm going to drop the link in the chat in case any of you want to read up some more on him. That's right, Alicia. He's a theoretical physicist. And I plan to do a stream. There are quite a few Black physicists as well, many of whom we don't know about, similar to the Black astronauts. So look out for something regarding that before the month is over. Okay, so going back to the CNN piece. Okay, this is the author of this piece right here, Don Lincoln. Don Lincoln is a senior scientist at the Fermi National Accelerator Laboratory. He is the author of several science books, including his new book, Einstein's Unfinished Dream: Practical Progress Towards a Theory of Everything. He also produces a series of science education videos. Follow him on Facebook. The opinions expressed in this commentary are his own. View more opinion pieces on CNN. Okay, if you haven't, please hit that like button. The likes are free and they help with the engagement. If a person is said to be grounded, it means that they are sensible and stable, solid individuals who can be relied upon to give careful and considered opinion. The very meaning of the term comes from the solidity and stability of the ground on which we walk. However, recent reports in the media have painted a different picture of what goes on beneath ground, one in which the core of the earth is doing something, is doing some very surprising and unexpected things. A recent paper published in the Journal of Nature Geoscience describes a change in the motion of the Earth's core. And with that news, headlines proliferated, some claiming that the Earth's core has stopped rotating. But the interpretation is actually misleading. The Earth's core is not literally stopping, however, it is changing. The Earth is not a solid ball. Uh, it consists of several layers. I'm going to show you all the picture again, and then I'll pick back up. That's what this illustration is showing us. The Earth is not a solid ball. It consists of several layers. There is the innermost core, which is a solid sphere. about the same size as the planet Mars. Surrounding that is the outer core, which is a liquid rock. The next layer is the mantle, which is a sort of taffy-like consistency. It's sort of taffy-like inconsistency. Finally, there's the crust, which is the outermost layer, the place where we live. If the Earth were a solid ball, every layer would rotate and sync, spinning once per day. However, because of the layered structure, it is possible for the core of the Earth to rotate at a slightly different rate from the surface and other layers. And in the 1990s, researchers used geological data taken over the previous few decades to show that the core of the Earth was rotating slightly faster than the rest of the Earth. The difference is tiny, about 1 degree per day faster than the surface of the Earth. This more recent study found that the rotation of the core is slowing. It isn't stopping, but is now rotating at the same speed of the Earth. Furthermore, it appears that the core might be slowing so that it will eventually rotate slightly slower than the Earth. This is scientifically interesting, but rather less dramatic than some of the headlines have suggested. Researchers have seen this periodic change in the speed of the rotation of the Earth's core before, and they still debate the rate at which it occurs, with some suggesting a 70-year cycle, while others suggest a much faster one. Okay. For geologists, this is fascinating stuff. The radius of the Earth is just shy of 4,000 miles, and the deepest well anyone has ever dug is a little over 7.5 miles deep. The crust under the Earth's continents can be about 40 miles deep, although the crust under the oceans can be much thinner. Figuring out the structure of the Earth requires indirect methods involving studying how fast the waves from the earthquakes travel through the Earth, or studying the rich treasure trove of data of how the sound from nuclear blasts pass through the Earth. With a few exceptions, nuclear testing stopped in the mid 1990s. So I'm going to make a quick comment or a quick speculation about what this gentleman just said about the thinness of the crust at the bottom of the ocean. So there are actually, and if there's a geologist watching this, and again, if you want to come talk, I'm always open to have guests. But uh, if I recall correctly, there are volcanoes uh, underneath our oceans, or at various locations underneath our oceans, which give off heat. And in some of those locations are in the polar regions. So one theory is that when you see, for example, sheets of ice break off, one question you also have to ask is what's happening underneath the surface of that water. Someplace like Antarctica or the Arctic Circle. There are a lot of things happening underneath the ocean that impact the ocean and things above ground. That's what I'm trying to say. And this is the end. Breathy headlines aside, this recent study confirms earlier results showing that the inner core's rotation changes over time and helps geologists trying to figure out the mechanism whereby those changes occur. What geologists care about is the interplay between gravitational and magnetic forces within the Earth that speed up and slow down the core's rotation. However, there is much more there is a much more important lesson to be drawn here, which is that scientists are able to make extremely precise measurements of what is going on under the surface of the Earth. This is a big deal after all. It's the only planet we have. What goes on under the Earth has huge consequences for humanity. Okay. So what's happening again within the planet underneath the crust, we don't control that. We have no control over that as humans. Consider the supervolcano that is slumbering below Yellowstone National Park. Every half a million years or so, or sometimes longer, Yellowstone transforms into a volcano that spews hundreds of thousands times of more ash into the atmosphere than the 1980 eruption of Mount St. Helens. While some have worried that perhaps the Yellowstone supervolcano is due for another eruption, recent studies have allayed the concern that the danger is imminent. However, given the magnitude of the damage such an eruption would occur, it is imperative that geologists continue to monitor what is going on. And there is much more going on under the Earth's surface. The Earth's magnetic field guides ships at sea and lost hikers to safety. It's easy to believe that the familiar compass will always work. However, geologists have shown that the Earth's magnetic field isn't constant. Indeed, every few 100,000 years, the field flips, with magnetic south becoming north and vice versa. So, everyone, here is a visual of that. Please hit that like button if you haven't. And if you want to donate something by Cash App or PayPal, that information is here. This is almost done. I'm going to finish up this piece. We're going to go over some basics of earthquakes. I'm going to say a few words about the earthquakes that took place this week, because there was more than one. And then I'll wrap the stream up. Let's see, we're at 38 minutes. Okay. And while a flip is probably not imminent, the location of magnetic north changes even on human timescales. So that's probably within 70 years or so. In the early 1900s, it was located in northern Canada. However, it has moved out into the Arctic Ocean and is now approaching Siberia. That's fascinating. By understanding more about the inner workings of the Earth, scientists will be able to help humanity prepare for significant changes in the Earth's magnetic field. If it happened, we'd have to change all instrumentation that relies on compasses to navigate. We have but one planet, and what happens inside of it can affect all of us. It is imperative that geologists continue to study what's going on inside our globe, and this recent measurement of changes in the rotation of the Earth's core gives us some comfort that we are staying up to speed. And come on and admit it, that's pretty cool. Okay. So there were two seismic events this week. There was one in my home city, and then there was a much bigger one over in Turkey. What I was thinking, as I was thinking about the stream, I was thinking to myself, how often are these earthquakes occurring? So let's go back about 12 years. The earthquake in Turkey, that's over in the Eastern Hemisphere, but the last big earthquake, I mean, if I recall correctly, the biggest earthquake in the Western Hemisphere took place in Haiti. I was thinking as I was linking these events together in terms of time, when was the Haiti earthquake? That was back in 2010. That was 13 years ago. And that was a big earthquake, but at least relative to that island. And from what I've seen, they're still recovering from that earthquake. I'm not going to read this. I'm going to drop the link in the chat. I'm going to show you all something, and then I'm going to wrap the stream up, because we should all learn something from these science and technology streams. We should all come away with something new. So I pulled this, let's see, where is it? Yeah. So what designates a small earthquake from a large earthquake? I pulled this from the Michigan Technology University website. I'll drop the link in the chat. It's also below in the description box. So according to this, so over in the right-hand column, that is the magnitude. The next column lists the effects. And then the far left column, that gives an estimate of the number each year. So magnitude 2.5 or less, those are usually not felt, but can be recorded by seismograph. And according to this, there are millions per year. So 2.5 to 5.4, those are often felt, but only cases, but they only cause minor damage. And there are approximately 500,000 per year. 5.5 to 6, those cause slight damage to buildings and other structures. And there are approximately 350 per year. Thank you for stopping through, Black Scorpion. 6.1 to 6.9. This type of earthquake may cause a lot of damage in very populated areas. There are 100 approximately per year. And a 7.0 to 7.9, that's a major earthquake. Those cause serious damage. There are 10 to 15 per year. And then finally, an 8.0 or greater, those are considered great earthquakes and can usually destroy communities near the epicenter. All right. So the magnitudes range from 2.5 to 8, 2.5 being the lowest magnitude and the most prevalent. And then when you get to the 8, then you're really causing some serious damage. Let me go back to that for a second to see how prevalent those 8s are. So the 8s are one every year or two. Okay, so once again, the Earth, the there's movement underneath the crust. There are multiple layers, and then the crust is always going through its own changes. So I guess every 1 to 2 years we can expect a big one. Extended clip says, I was in the Loma Prieta in 1989 in the Oakland Bay area. Yep, that was the one that was on TV. If you're new, please subscribe to the channel. So earlier this week, I woke up and where is it? There was a 3.8 earthquake. I think well, that was to the Buffalo News. I think for some of these articles, if they let you look at it once for free, and then once you go back, they throw up the paywall. So with this article is from the Buffalo News, and it stated that the earthquake in Buffalo was a 3.8 earthquake. That one hit in the morning, and both my mother and my brother said they felt like something hit the house. and multiple people around the city said they felt that same thing at that time, early in the morning. Now, there also years ago there was an earthquake here in the Washington D.C. area. And I was talking to someone earlier this week about it. I was sitting in my cubicle near Ronald Reagan Airport, and there are train tracks behind our building. And when the trains would go by, you could feel the building shake. But when the earthquake hit, it was different. It was different. You could feel the floor go like this, and it was noticeably stronger than the trains going by behind our building. Aquateki says that was 2011. Yeah. And me and my one of my coworkers, we kind of looked at each other and we said, "Did you just feel that? Did you just?" And when I got back here, some of the things had fallen off the shelves. I remember that in my closets. So, so we've had, so we do experience. California typically is known for earthquakes in the United States, but here on the East Coast, in the Caribbean, there has been activity within the last 15 years. Okay, so let's talk about what happened in Turkey just briefly. Let's see how damaging that was. So Buffalo was 3.8. Yeah, so that was, they felt it, but it only caused minor damage. Yeah, and those are pretty prevalent throughout the year. But what about Turkey? In Turkey, it was pretty bad. Let's see. I pulled this from NPR. I consider NPR to be a very, very reliable source. Okay, yeah, that was okay. I'll pull it up and show it to you all. Okay, this is entitled "As the Earthquake Death Toll Soars, So Does Criticism of Turkey's Government Response." You can see all the workers there in the background, and that is Turkish President Recep Tayyip Erdogan. Okay, and he's touring the wreckage of one of the buildings. I'm not going to read this, but yeah, that was a big one. That was 7.8. 7.8. And so let's go back to our scale. That's right there at the top. Major earthquake, serious damage. Okay, and that's right on the cusp of 8, which is a great earthquake, which can totally destroy communities near the epicenter. Okay, so everyone, all of these links are, oh, Aquateki, I didn't know that. I didn't know that. Akoteki, I'm sorry, T Riddler. T Riddler said the 2011 quake cracked the Washington Monument. I didn't know that. Yeah, I didn't know that. Um, the Bro Genius says Erd Deranis is the pronunciation. Erd Deranis. Thank you very much. Okay. So everyone, all of those links are below in the description box. This one, I think about what to present every week. And sometimes the ideas just kind of magically coalesce and come together. But I've been seeing these articles about the Earth's magnetic pulse shifting and the core slowing down. And I've been seeing these, and I was just thinking of a context in which I could present this. And this week, we had two earthquakes. One that for me hit close to home, and then one, a much bigger one, over in Europe slash the Middle East. And you know it's big when the UN has to get mobilized, and all the well, many of the global partners have to mobilize and assist. So it was a huge one. So that's the take home from this stream, and that's that there are things happening within our planet. I'm going to show this image here. There are things happening within our planet. There are layers to our planet, and there are processes taking place that man does not influence. And I think that's just important to keep in mind for our general knowledge, and also when people are talking to you about certain things, keep that in mind that there are processes happening within the planet and then outside of the planet that we don't impact. And the Earth is not its own singular body. It's in a whole solar system with the sun and other planets, and there are numerous processes taking place within our planet itself. Extended clips. Are you saying the earthquakes are ongoing? Is that what you're saying? Is that what you're saying? Extended clips, that there's more. Aquateki says, for every action, there's an equal and opposite reaction. Earthquakes and volcanoes are just the Earth balancing its equations. That's a good way to look at it. I was about to show something else, but I'm blanking, and that's okay because I should probably wrap this up. So, everyone, I'm going to wrap this up. Thank you to those of you who came in and watched and hung out. I hope you got something from this. Hope you got something from this. If you're new, please like, share, and subscribe. But if you want to donate something to the channel, that information is here. Also, please consider joining the Big Words LLC newsletter. That is here. There's a 2-paragraph greeting. You just hit that subscribe button there at the bottom, and it brings up this form, and you enter in your email address, and boom, you're part of the group. And there's also an email address that I set up for the newsletter, which is in the description box below. So there are multiple ways you can sign up for this, and I appreciate every name. So with that, I'm going to wrap this up. Please let me know if you have any questions or comments in the comments section below if you're watching on the playback. And once again, if you are an expert on any of these fields and you're open to having a Q&A to educate us on any of this, or things that we don't know, uh, my door is always open. Aquateki, thank you for the Cash App. I always appreciate the support. I'm going to show this slide one more time. This was from a climate discussion, and I think it just drives home the complexity of the Earth and the seismic and the climate related events associated with the Earth. So this one says, what is climate? And this doesn't just apply to climate, but it applies to I think it applies to everything. What is climate? What area of expertise is required to master it? An understanding of climate requires an amalgamation of astronomy, solar physics, geology, geochronology, geochemistry, sedimentology, tectonics, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, and history. Okay. I would argue that this applies to the events that we saw this week as well. All right, everyone, take care, and I will talk to you the next time. There's someone I want to interview, and I have to reach out to him that is on the list. So look for a notable interview to take place sometime in the near future. All right, everyone. Enjoy your weekend. I will talk to you the next time. As always, remember that your attitude determines your altitude, and always try to do your best. Take care, and I will talk to you the next time. Bye bye.